Now for the last one, calculating payments, saving up for a goal. Suppose we want to have $500,000 when we retire in 40 years, and we can get 1.5% interest compounded weekly. How much will we need to put aside each week? So, first of all, we have the formula, which is the payments are going to be R times the final amount we want to have over 1 plus R to the YN, not to the negative YN because this is saving and not paying off a debt, minus 1. What have we got? The final amount that we want to end up with $500,000. The number of years is 40. N is weekly, so that is 52 times a year. And our rate of interest is going to be 0.015 divided by 52. We don't get 1.5% every week. We get 1/52nd of that. We share that over the number of weeks over the whole year. Anyway, we plug it right in. So it's going to be 0.015 over 52 times positive 500,000 divided by 1 plus 0.015 over 52 to the 40 times 52 minus 1. And why don't I show you, just because rather than do it the same way every time, why don't I show you a slick way of doing this all in one go. First we evaluate the bottom by doing parentheses first, and then the exponent, and then the adding and subtracting. So 0.015 divided by 52 is some tiny number. Add 1, we get 1.00, a tiny number. We raise that up to, in parentheses, 40 times 52. I couldn't necessarily do that in my head, but if I do the parentheses, it figures out that that's the 2080 is 40 times 52 equals, that's the number. I subtract 1, I get that number. That is my denominator. I could write that down, but I love this 1 over x button. Now all I have to do is multiply by the top, and multiplying and dividing are all kind of the same thing. I just start multiplying. Times, did I say times? Times 0.015 divided by 52 equals times 500, 1, 2, 3, hopefully I didn't mistype anything, $175.47. $175.47. So, how nice is this? Well, what did we say? What is 175 for? So in other words, if you want to have $500,000 when you retire, you should put aside $175 a week, and you'll be all right. That's a lot of money. I mean, we were saying that $500 for a monthly car payment is much. This is almost $200. This is almost $800 a month. If assuming that there's 4 weeks in a month, and there's more than 4 weeks in a month. This times 40 times 52 is the total number of payments, the total amount of money that you put in. That number's already there. Times 40 times 52 is... But see, here's the beautiful thing about interest. Over the course of those 40 years, you will have put in a total of $364,980. $364,980. $364,980, and the other $135,000 is interest. And this is why. And the amount of money that you pay early has longer to accumulate interest. And so this is the paradox. The paradox is you get right out of college, you want to buy a house, you want to buy a car, you want to start paying off your student loans. The last thing you're thinking about is the money that you're going to want when you retire. But every dollar that you put in when you're 25 years old is going to be, say, $3 or $4 when you retire. Every dollar that you put in when you're 50 isn't even going to double by the time you're 60, unless interest rates change. They probably are going to change, but if they go up, it's probably going to be because inflation goes up, and if inflation goes up, $500,000 might be diddly squat in 40 years. But, life is hard. Life is hard. Can I double check this? I don't feel like double checking this. This is how it works. So remember, If you're saving up, the interest is helping you, you don't have that little plus, that minus in front of the yn. I'm going to keep them separate by putting a little f there, meaning you're going for a final amount as opposed to thinking about the initial amount of money that you're starting off with, the initial amount of debt. On a test, I'm going to give you these formulas. I'm not going to explain these formulas. On a test, it's just going to say f equals a1 plus r to the yn. It's going to say f equals ra plus p to the 1 plus r to the yn minus 1 over r. It's going to say p equals ra over 1 plus r to the minus yn minus 1. It's going to say p equals rf over 1 plus r to the positive yn minus 1. And it's going to also say y equals log of p over ra plus p over n times log of 1 plus r. And you're going to have to know A, what all these letters mean, B, how to pull them out of a formula, how to calculate these on a calculator, and also what does each of one of these mean. If I say you want to buy a $200,000 house and pay it off in 30 years with 4% interest, what are your mortgage payments going to be? Which of these formulas are you going to use? So it's not such a bad idea to start looking at these formulas all at once and thinking which one goes where. But that is it for today.